السلام عليكم متابعين وخوينكاراني عزيز لهر شوية وكردستان صلاوتان لي إن شاء الله سلامت من لو عنيتي نوي دزكين بتو ماركردني بابەتەکانی کیمیای سیستەمی ئینگلیزی پۆلی دوازە بۆ ئەمڕۆ دەست دەکەین بە باسکردنی چاپتەری چوارم ئۆکەی بۆ هیوایم کەوە توانێ بێتان سێ چاپتەرەکەی سەرەتاتان مەزبوط کردبی ئینشاءڵڵا و ئەگەر هاتوو کەم و کوڕۆشی هەبووبی ئەوە دووبارە ڤیدیۆیەکان سیرکەنەوە هەوڵدەن گرنگەوەیە بێ هیوامە بن ئینشاءڵڵا زۆر باش دەبن بە ئەکیدی کیمیا بابەتەشی ئاسانە تەنها کەمێک زۆرە و کەمێک وەختی. Okay, chapter 4, it's something like physical chemistry. It's not a pure chemistry, physical chemistry. We're going to deal with the amount of energy that is released or absorbed during a chemical and physical changes using a branch of chemistry which is called thermochemistry. Okay, chapter 4, it's about the thermochemistry branch. Very good. Look, thermochemistry, let's take a definition of thermochemistry. Is the study of transfer of energy that accompany chemical and physical changes. It means we will have a physical and chemical changes. Then during these changes, always energy must be involved, of course. So this branch of chemistry that deals with this amount of energy that is released or absorbed during a chemical or physical change is called thermochemistry. Okay? The energy absorbed or released as heat in a chemical or physical change is measured by a device which is called calorimeter. First of all, calorimeter, it's a device, it's a machine, it's an instrument, an equipment that used to measure the amount of energy that is absorbed or released. Sometimes instead of absorbing or releasing, we will say transferring, okay? Transferring, it means, transferring of energy, it means energy that is absorbed or released. Transferring includes either absorbing or releasing, of course. And also we have something close to this, which is thermometer. Thermometer is used to measure the temperature, you know this. Let's have a look of the graph of simplest combustion calorimeter. This is a simple combustion calorimeter. So in my opinion, if you find a white page and let's draw the simple combustion calorimeter graph, I'm going to mention the main parts of the simple combustion calorimeter. First of all, the name is simple combustion calorimeter. Simple combustion calorimeter. Stay with me, my dear. So let's learn how to draw the simple combustion calorimeter. Okay? Look. A simple combustion calorimeter contains two boxes. The outer box, okay, which is called steel container. This is the outer box, made up of steel, of course. This is called steel container. Good. And the inner box, which is called steel bomb. This is a steel bomb. Steel bomb. Steel bomb. Okay, steel bomb. And of course, you know, it must be covered with a protection layer as an insulator to prevent the amount of heat inside from escaping, or we don't know, the outer temperature affects the inside, okay? So it must be covered with an insulator, okay? And then between the two steels, between the two steels, there must be enough amount of water between them, okay? So here we have enough amount of water. This is enough amount of water, of course. Assume this is enough amount of water, my dear. بخوای لو جوانترم پیدروز نکردی. اوزا قليل رسمه كم مكان تخوا. قريقة ويا ليت إبغان. يعني لو جوانترم هكوري إشي بيان هلا وهذا أخوي. Okay. So this is H2O. H2O. أو تسي بيدلين بابي من. Come on. Okay. This is H2O. Well, let's repeat the whole things. The outer container, which is called steel container, and the inner container, which is called steel bomb, between them we have H2O. And there's one more important part here. This is called thermometer. Thermometer. Nice. So we have thermometer, steel container, H2O, and steel bomb. Get? Okay. The things are happening inside of the steel bomb. The reaction takes place inside of the steel bomb. That's why the name is a steel bomb, because it will become like a bomb. It's gonna be filled with energy, because this is the name of this is simple combustion calorimeter. Okay, this is a simple combustion calorimeter. We have steel container, steel bomb, enough H2O. Okay, I'm going to tell you what's the reason of this and what's the reason of thermometer. And then here we have the other part, which is called sample dish. Oh, sample, yeah. We're going to put the substance inside of this. This is a sample dish. Okay, sample dish. It will contain the sample. Okay, we will contain the sample inside of this. Okay. Then for any device there must be a starting bottom or start bottom. Okay. In this case, instead of starting bottom we have two ignition wires. These are called ignition wires. Ignition wires. You know, we have ignition wires to initiate the reaction. And then inside of the sample bomb there is something which is called pure oxygen. So the sample must be combusted under the presence of pure oxygen inside of the steel bomb. Well, now it's time for the process. Look, we will put the sample here. Okay, the sample must be contained here, right? Then we will press the starting bottom, which is called ignition wire. The reaction started. Once the reaction started, okay, the sample must be combusted, burned under the presence of pure oxygen. Then, of course, this is obvious. It releases energy to the steel bomb. It warms up the steel bomb. Okay? يعني steel bomb get him daddy. Once the steel bomb is warmed up, then you know the energy will be transferred to water here. So, Mr. The duty of water is to absorb the amount of energy that is released by the steel bomb. Yeah, exactly. Okay, then we have thermometer. Thermometer measures the initial temperature and final temperature. Then we will calculate delta T. Good? After this, we will introduce delta T in some rule, in some formula to calculate the amount of energy, which is normally symbolized by Q or something else. Good? Then, بعدين هميدو باركينو أبروسي. A calorimeter contains steel container and steel bomb. Between the two steels, we have water. The reason is to absorb energy from the steel bomb. Then we have sample dish. We will put the sample here. We have thermometer to measure T final and T initial to get delta T. Then the sample must be combusted under the presence of what? Pure oxygen. Okay? Then we have ignition wire to initiate the reaction, to start the reaction, of course. Yeah. Once the reaction started, it releases energy to the sample bomb, to the steel bomb. The steel bomb بقى سيلي ده باب گرم دبي. كگرم بو او گرمی دات اوی. اوش گرمی کی وردگی. پاشان لیره چی معنیه؟ Thermometer معنیه temperature initial و temperature final معنی بو measure دکا. Then we will get delta T. After this, we will use delta T to calculate Q using some rules. Okay? So the point is, Q, which is the amount of energy, cannot be measured directly. Why? Because the data collected from the calorimeter is the change in temperature. Then we will use the change of temperature to calculate Q using some rules. So this is called indirect calculation or indirect measurement of energy. Okay? So our رسمية simple combustion calorimeter. خاله gringa كانسيا كاكا thermometer معناه دلتا تي مانو calculate دكا باشان بوي دلتا تي كي calculate دكا تيتر معناه pure oxygen بكاردي ليرا oxygen پاک بكاردي oxygen خامن بكاردي او پیدالن simple combustion calorimeter energy راستو خو direct measure دكريان indirectly of course indirectly تمام هر اوندا أظن الرسمة كتاب جوانت درچوال. Okay. بابر دام بين. So the data collected from calorimeter is the change in temperature because there is no proper way to measure energy directly, or it's not a practical way to measure energy directly. So it's not for some energy directly calculate the crayon indirectly, just say Mr. indirectly, because there is not a proper way to calculate energy directly. Very good. Let's read the whole phrases here about the simple combustion calorimeter. Look at this. This is the diagram, the one from the above, okay? The diagram of a simple combustion calorimeter. A weight sample, it means a given amount of sample is ignited by an electric spark, okay? And burned in the sample dish under the atmosphere of pure oxygen. It means the pressure must be 1 atm. Must be what? Must be 1 atm inside of the sample dish, inside of the steel bomb. But the amount of, the oxygen in there, it's not from the air, it's from the pure oxygen. Okay, we will use pure oxygen instead of air, The energy generated by the combustion reaction warms the steel bomb and the water surrounding it absorbs the energy. Get it? Thermometer is there to measure the initial and final temperature. Then we'll calculate delta to calculate energy. Okay. You may often ask, there's no difference between the temperature and heat, but actually, we have some differences between them. Okay, temperature is different from heat. Heat is different from temperature by the following points. Look, heat, first of all, it's a form of energy transferred between two samples due to the difference between their temperature. Example, so قالوا ما لازم من بدايات سارده لبرسبليتي بس دستي من جرمه كدستي ده كمان قلمك جرم دبي لدستي منه جرمي له قلمك يدسي جرم ده تاوكو جرمي دست مو قلمك وتشيشي ليدي then the transferring energy will be stopped. Look, energy transferred between samples of matter because of the difference between their temperature. The transferring of energy will be continued until both subjects are reached the same temperature. Good. But temperature, okay, it's a measure of the average kinetic energy. Average kinetic energy, okay? Good. Average kinetic energy. Never forget this. The unit of measurement here is kilojoule or joule. You know this kind of conversion, okay? And it cannot be measured directly. But this one, the units are Celsius or Kelvin. However, we have so many different units for temperature. But in the book, in the 12th grade, in grade 12, we only have these two units for chemistry. and it can be measured directly. That's all. I'll get back to this, and this is obvious. Look. Okay, we have specific heat, CP. 2 marks. هو يعني هیچ مەجالی تێدا نییە. یەکە لەو بابەتانەی هەمیشە لە ئەسیلەی وزاری دەیبینی دێتەوە. بەئەکیدی دێتەوە یعنی چت پێ بڵێم کاک. وا پێ دەڵێم دێتەوە. So let's take 2 marks here right now directly. Good? We have CP. What is CP? First of all, CP, it's a property. It's a nature. It's a property of the substance. Okay, look. Explain CP is the amount of energy. From now on, try to symbolize amount of energy by Q. Okay. Is the amount of energy that is required to raise the temperature. Raise the temperature, it means delta T. Okay? Okay. Is the amount of energy that is required to raise temperature. It means we need an amount of energy to raise the temperature. Okay? Of 1 gram of the sample. Okay, gram here symbolized by M. We have 3 variables related to CP. Q, delta T, M. Using these 3 variables, we will generate the formula of CP. Okay, let's get back to the definition. The amount of energy that is required to raise temperature of 1 gram of sample by 1 Celsius. This is the value of delta T. Okay, or 1 Kelvin. Remember, delta T in both scales, delta T for both scales must be the same. I mean, delta T by Celsius equals to delta T by Kelvin. Good? Okay, it's about this. So the rule of CP. CP equals to, CP stands for what? Specific heat. T, specific heat. لبركة دي. CP تيا specific heat. Okay, CP equals to Q over M delta T. CP دكاتة T, Q over M delta T. Q over M delta T. Oh, CP. ماشي. Q تيا. First of all, CP is the specific heat at given pressure. Okay, at given pressure. What do you mean by this? Because this is the only factor that influences CP. This is the only factor that changes CP. So CP can be changed by what? Only by CP. But Mr. How about QM delta T? Just wait. آخر ما مثلا كولير لقى QM delta T ناقور CP ناقور باب. Okay. Look, CP is the specific heat at given pressure. Q here, the amount of energy, okay, energy transferred can be gained or, or lost. So this is called transferred energy used in joule, okay, or different units. M is the amount of the substance, normally is measured by grams. Delta T, represents the difference between the final and initial temperatures. It stands for the change in temperature, delta T. Okay, look, CP دكا QM delta T, Q amount of energy, amount of the substance, and amount of the change of temperature. Okay, 3 amounts. Good. The units. Q is measured by joule, kilojoule, and calorie. Delta T is measured by Celsius or Kelvin. M is measured by grams or by mole. Okay, so if we combine them, we can create a huge number of or different. There will be a variety. We have variety units for CP. We have too many different units of CP. Be careful. Look at this. Example. Look. ليركو أنا هم من هي باش شبابي من. بقول من لبو Q. For example, Q can be measured by joule, amount by grams, temperature by Kelvin. This is one of the units. Another one. Joule, gram, Celsius, or calorie, gram, Kelvin. So it's up to you. Look, Q is measured by calorimeter, joule, kilojoules. Okay? M is measured by grams or mole. Grams or mole. Delta T is measured by Celsius or Kelvin. So it's up to you to create any unit using them. Example, I'm going to show one of them, okay? So select one of the units of Q. Example, joule, okay? For M, select gram, for example. For temperature, select Celsius. So you can keep going like this. It will be around 32 or 35 different units. So now all of the following units are units for CP, are suitable. They are, proper units for CP. Okay, look, etc. It means we can have too many different units for CP. Good. This is a wizardry question. Specific heat usually measured in what? Is this true for Q? Yep. For M? Yep. Temperature? Yes. This is correct. Q, M, temperature, yes. Q, M, delta T, correct. All our units are correct units for CP. We have something to learn about CP, my dears. I'm going to open a new page. Good. CP equals to Q, M, delta T. Nice. So if we calculate Q equals to CP times M times delta T. Right? Multiplication for the whole variables. Look at it, my dear. CP cannot be changed with changing. CP cannot be changed with changing Q, M, delta T. أو كو ما مساوشته. أما لما في خوينديتمان لفيزيكسي خوينديتمان the one that must be calculated is directly proportional with the numerator and inversely proportional with the denominators. But here, why? Okay, this is the same as density. Density equals to mass per volume, okay? Density is independent to mass and volume. There is no relation between them with density. This is called intensive property. This is intensive property. Hopefully you remember we have two different properties based on the amount of the substance. Intensive properties and extensive properties. Okay? CP, this is a nature of the substance. This is what? Nature. Look at this. Think about someone, okay? For example, we will talk about a boy, okay? He has the special nature, right? Okay? No matter if he's fat or thin, the nature is the same. يعني اگر او کسی قلوبی ضعیف بیتن طبیعتی هر وقت خویتی ناگوره باشا او ماسه يعني بارستایی وزنكي كسك ماني كاكا قلوبي ضعیفی طبیعتی هر وقت خویتی. Okay. No matter if it's winter or summer, the طبيعة is the same. گرینگنیه بهار بی پاییز بی زستان بی هرم بی طبیعتی کسکی هر وقت خویتی ناگوره. Again, no matter if you talk, if you motivate him or not, the طبيعة is the same. يعني هتاي وارق سيلو كطبيعتها وش خوتي ناغوري. The only thing that can change his behavior is slapping. Okay? عن شون طبيعتي بيدا غوري بزبر الشاقي طبيعتي اقب غوري. اما ليلة بيدرين pressure زخت. يعني اقيل زختي لي بكي كسك طبيعتي دا غوري. انا قلوبي زعيف بيها طبيعتي وش خوتي. زستان بيها بطبيعتي وش خوتي. سيلوب كان اگه طبيعتي هوش خوتي تاكشت كطبيعتي لو انا كمك بغوري اوش زخت اگه زور زختي يبكي لا انا كمك بغوري. Okay, so the only thing that changes CP is the pressure. Is what? Pressure. Okay, let's calculate Q equals to CPM delta T. Good. Look, Q is the amount of energy. Q is directly proportional with CP. It means if we change these variables, CP cannot be changed. But changing CP changes the whole things. وقتا أنا مو بقولين CP هر ناقوري. بلام أنا بقولين CP ناقوري. بلام أجا CP بقولين أنا هم دقوري. باش شبابي من؟ Okay. Q depends on the nature. This is mass, amount of the substance, and the size of the temperature change. Good? Look. The quantity of energy transferred as heat during temperature change depends on what? Okay, depends on what? The nature of the substance, it means Cp, the mass of the material, m, and the size of the temperature change, delta T. Okay? Look, what is the benefit or what is the goal of Cp? Cp is used to compare the absorption capacity of different substances. And Cp Cp is used to compare the absorption capacity of different substances. Try to have this note. The one with greater Cp absorbs more energy. The one with greater Cp absorbs more energy. The one with smaller Cp absorbs less energy. Example, we have two substances, A and B. Okay, Cp for A equals to 0.2 and for B equals to 0.25. I mean Cp, of course. They have the same mass, okay, and they have been heated by the same amount of energy, the same amount of heat, the same source of heat, okay? Which one absorbs more energy? I remember there's a note in the book, or based on the rule, the one with greater Cp absorbs more energy. So this one absorbs more energy since they have the same mass. Great. A 4 grams of a sample of glass was heated. Okay, gram stands for M. From 274 to 300 Kelvin, this is delta T, was found to have absorbed 50 kilojoules. This is Q. Mister, now we have M, delta T, and Q. Look at this. M is 5 grams, and we have delta T, we have Q. Directly find Cp, then use Cp for the main unknown. Done? هر دیتی ده باشا. Wara babardon binera. Sorry, let me have a sip of water. Okay. Look, it's okay to have molar mass to convert grams into mole or mole into grams, right? So using molar mass, because the relation between mole and gram is the molar mass. So if you have molar mass, that means, please, okay, read the question carefully. There must be some conversion for the unit of mass or amount of the substance. It's okay to have mass in grams, amount of substance in grams, then we can turn the mass into mole, or it's okay to have mole, then we can turn mole into grams. Using what? Molar mass. But remember, it depends on we will calculate this according to the question, according to the unknown. The question must specify which unit is the desired one. Look at this, my dear. Unit 7T, look, 70.2 joules to raise the temperature of 34 grams of ammonia. So this is Q. And now here we have mass, okay, NH3. To increase temperature from 23 to 24. These two temperatures are used for delta T. Nice. Calculate specific heat of ammonia by, try to add this part, this is a missing part, you have to write this, by what? By joules mole Celsius. Again, calculate Cp by joules mole Celsius. Look, the amount of the substance is given by what? By grams. But the question said find Cp, and in the unit of Cp, the amount of the substance must be in mole. So you should calculate number of mole first. Mole equals to mass over molar mass. We have the mass of the sample, which is 34. Molar mass of NH3 is given, which is 17. Mole equals to 2. And now, okay, Cp equals to Q mole delta T. We have Q, which is 70.2. Mole has been calculated, which is 2. The only one is delta T. Okay, delta T equals to T final minus T initial. 24 minus 23 equals to 1. Okay, delta T has been calculated also. It's easy. Good. This is the same, so I'm going to leave this for you. Try to solve these questions, please. I'm not going to waste our time with this. I've explained the whole thing is here. Okay. This is the most challenging question related to CP, and at the same time, it's nothing really. It's nothing, yeah. So let's solve this question together. لەگەڵم بنتخوا ئەو پرسیارەیە لەناو پرسیارەکانی CP لە هەمان دوور درێژترە بەڵام زۆریش ئاسانە و چەند جارێکش لە وزاری هاتەوە تا ئێستا 2000 هاتەوە ئەوەندەم ناکەم دەیبی ئەو زە نازانین ئاخۆ لەمە دو زیاتریش دێتەوە یانە بەتینۆ وزاریە هەرچ پرسیارێکی ناو کتابی ئەگەری هەیە بێتەوە احتیاطیە. Okay. If 980 kilojoules Q is given. Okay, با ڕەنگەکەی بگۆڕین. بێزار بوومەوە ڕەنگەی هەر بەزدی. دەی گۆڕمەوە ڕەنگەی کاکە. دەی کەمە blue. Yeah, blue. Okay. Oh, blue لەکنە من. Q equals to 980 kilojoules. Q is given by what? Q is given by kilojoule. 980 kilojoules. Good. Our Q given up. Of energy are added to 6.2 liters of water. Okay, so volume is given, which is 6.2 liters of water. At 291 Kelvin, okay? This is a temperature, but we don't know what is the, this is what temperature, final or initial, get? What will be the final temperature? Okay, calculate T final. That means the given one is T initial. T initial is given equals to 291 Kelvin. CP is given. CP equals to, get 4.18 joules, grams, Kelvin. Very nice. So we have the following givens. But there's a very important point. If we have CP, the point is, look, if we have CP like this, all the rest of the units must be arranged according to the unit of CP. يعني كو يعني اگر CP مانها بوده بي همه يونت كان وكو يونت CP ليفكن باش شبابم تمام. Look, CP mandale CP, okay, according to the CP the amount of energy must be in joules, but now it's given by kilojoules. So this will be the first duty of the question. Kilojoule must be turned into joules because of the CP. Good. Another one. The amount of the substance must be in grams, but now it's in liter. This one must be turned in grams. The most challenging conversion in this section. Okay? So how to convert this? The relation between mass and volume is density. Is what? Density. So the relation between mass and volume is density. Look at this, my dear. Let me show you. By the way, how to calculate T initial? We have delta T. Delta T equals to T final minus T initial. So how to calculate T final? T final equals to delta T plus T initial. Okay. So we have to calculate, we should calculate delta T. Look at this. CP equals to Q over M delta T. We have CP, we have Q, we have M, but we don't have delta T. We will calculate delta T, then we will substitute delta T to here to get T final. But none of the units is safe. So let's convert the units. First of all, kilojoule must be turned into joule. How? By multiplication. Multiply this by 1,000. Okay, Q equals to 980 times 1,000 will be 980,000 joules. The first one. Okay, Q is ready. About M, how to convert volume in liter. How to convert volume in liter into grams. Try to use this technique. This is a very easy technique. Look, 1 liter equals to 1 kilogram equals to 1,000. Look at this. Babu Shazi Godmusum. 1 liter. How to convert volume in liter into grams. Look at this. 1 liter equals to 1 kilogram, right? Equals to 1,000 milliliter equals to 1,000 grams. Just wait, just wait. This is not always true, okay? So now, look. The volume is given by what? Volume is 6.2 liters. So if 1 liter is 1 kilogram, how about 6.2 liters? So equals to 6.2 kilograms, right? Equals to, time multiplied by 1,000 the beta, 6,200 milliliters equals to 6,200 grams, right? طبعا یک لیتر دکاته 1 کیلوگرم دکاته 1000 میلیلیتر دکاته 1000 گرامش عادی 6.2 لیتر اوکی 6.2 لیتر دکاته 6.2 کیلوگرم دکاته 6200 میلیلیتر 6200 gram. But the point is the result must be multiplied by the density. Okay, Mr. Now gram is 6,200. Okay, mass equals to 6,200. But the point is, the substance is water. You should memorize density of water is 1, right? So multiply by 1. Always multiply this result by density. Good? اگر milliliter معنی بوشه از یک gram, kilogram, gram, liter, gram borule. But remember, the result must be multiplied by density. Since the substance is density is water, so density of water is 1. But if we have something rather than water, the density must be given. Then multiply the result by density. So M equals to 6,200 grams. Now we have grams, we have Q, Cp is given. So it's okay to calculate delta T. Okay, I'm going to solve the question here. Cp equals to Qm delta T. Nice. Cp is 4.18 equals to Q is 980,000. Gram is what? 6,200 times delta T. We should calculate delta T. So delta T equals to, I think, equals to 37.8 or something like this Kelvin. Then substitute delta T here. You will get T final. وش رازي بسيارة حل دبي زور بعساني. So ليرو كوتايم ببابتي سي بي هنا إن شاء الله درسي داوي we will learn how to write the combustion and formation reactions. Be careful. The next lesson will be very important for the rest of things, for the rest of other things in chapter 4. So make sure to not lose any second in the next lesson. تاوكل بخواتنا نسبين بخواتنا